So I really started with the broad question, very broad question of what does it mean for mental health, particularly depression, to be transgenerational? We know, there are a lot of environmental risk factors there that plays an important role, but I really was interested in this genetic component. As a family nurse practitioner, I do work with people who do have anxiety, depression. I can hear from women their experiences, and that also sparked the additional question of, okay, if this is transgenerational, really understanding what it means if a woman has depression during pregnancy, across pregnancy, what could that mean for mom's mental health in the postpartum period as well as the child's mental health. A mother having depression during pregnancy, we think about her ability to bond with being pregnant and then with her child as a newborn. We know that's a really crucial developmental period for children as they're growing, and having that bonding, is very important for both mom and for a baby. So oxytocin is a love hormone or social interaction hormone. Across pregnancy, it has important implications. It has important functions for delivery, but it's also doing these things in the brain as well and be important in regulating emotion and that social interaction. Each of us have our own endogenous oxytocin, which means that our bodies are already producing it. The way to understand how oxytocin is being used is to assess its receptor. So if there are changes in the gene receptor, that may have implications for how oxytocin is being used and could have important implications for that social interaction. When we're already producing it, how does adding in oxytocin in the form of synthetic oxytocin, in humans we use Pitocin, what does that mean and how does it change the brain and the blood? Increase of the methyl group that's added to the gene will actually suppress the expression of the gene, and that can have implications for, again, continuing on with symptoms that we would say might be related to postpartum depression or depression anxiety. My work in clinical practice is working with humans. However, we can't do some of these invasive procedures and take brain samples and see if there are correlations between the brain and the blood. So is how the genes are expressed in the brain the same as what they are in the blood? And we want to do that because then we don't have to take brain samples. We can draw blood from people, and that can be used in a clinical practice setting. For this particular study, we will be using the Prairie Vole and examining both brain and blood samples to see those relationships between the brain and the blood. If there are correlations, that can be a very good indication that we can use that as a proxy in humans as well. We can draw blood samples, and that can give us an idea of what the brain is doing as well. The oxytocin in the brain is doing as well. There are studies that are showing long-term consequences of using exogenous oxytocin for outcomes of postpartum depression. Oftentimes, we will use medications in practice for an important reason. We definitely want to reduce and eliminate this postpartum hemorrhage. It can be a very serious complication. And so this has life-saving effects. However, use of Pitocin, yes, though it's important, there are also risk factors associated with it. So all medications have side effects and have, consequences. And so if we are able to recognize that it's good to use, it's, has been helpful, but at the same time, how do we individualize it so we can reduce those potential negative effects that we don't want down the line?